Good morning to all. Right. In last class, any doubt? No. Okay. Okay. Listen properly. Now we are going to discuss about current loop as a magnetic dipole. Okay. Listen. So this is very important. 3 mark or 5 mark question. Listen properly. 3 marks or 5 marks. Okay. First, before going to discuss theory about this, you must know about what is the meaning of title. That is important. Okay. Current loop like this acts as a magnetic dipole. What is magnetic dipole? Like bar magnet. I am correct or not? This is bar magnet. It is consists of 2 poles, no? North pole and south pole. Like this. When current flowing through it, that means through circular loop or coil, this also acts like this bar magnet. With respect to current flowing through it, one end acts south pole and other end acts north pole. With respect to the direction of the current flowing through it, that is important. Keep it in mind. Clear? Okay. At the same time, already you have discussed about magnetic field along the axis of the circular loop carrying current in last question. I am correct or not? Come on, tell me what is the formula. The circular loop carrying current I. The center of the current loop. Let us consider small a. Area of the radius of the current loop. This is one point P. Along the axis of the current loop. At a distance x from the center of the current loop. Okay. So field at this point B is equal to mu naught Ni A square by 2 of A square plus X square whole power 3 by 2. Okay. Radius of the circular loop. Distance from the center of the loop. Field will be along the axis of the circular loop. Okay. So at this point, this is the value. If n is equal to 1, that means 1 turn. Okay. B is equal to mu naught Ia square by 2 of A square plus X square whole power 3 by 2. Okay. Okay. This is field due to circular coil along the axis of the coil carrying current. If n is equal to 1, that means the number of turns. If 1 turn or for a coil, one coil, single coil, this is a field value. From the center of the current loop at a distance x at this point, its value. Suppose what will be the field value, that means magnetic field value at the center of the circular coil or loop? Think and say. At the center of the circular coil, at the center of the circular coil, at this point this value, okay. Center of the circular coil, x is equal to, at this point 0, very good. X is equal to 0. Therefore, B is equal to mu naught E square by 2 of, this is 0 no? Therefore, A square whole power 3 by 2. 2 to cancel. So, B is equal to mu naught I A square by 2 A cube. Cancel. So, B is equal to mu naught I by 2A for single coil at the center of this current loop. Okay, this is basic formula. These formulas just you use while solving the problems in NEET examination. Okay, but NIA square like NTA, because this formula it is very simple to remember. That's why I am using this type of symbols. But according to your new textbook, listen, new textbook, what is this? Already told you. Radius of the loop, I am correct or not? Distance of the point P from the center of the loop. So, instead of A, you must put R. Instead of X, just you use Z according to new textbook. Okay, so come on, listen. B vector is equal to mu naught I R square by 2 of R square plus Z square whole power 3 by 2 K cap. This is according to new textbook, magnetic field along the axis of the circular loop carrying current I. Okay? Listen, okay. Radius of the current loop. Distance of the point P from the center of the loop. In last question, you have studied about the same, correct or not? Like this. Here, this is the field direction denoted by K cap. So this will be, this gives us direction of the magnetic field. Okay, that's our K cap. So at a larger distance, Z very greater than radius of the circular loop. Am I correct or not? At a larger distance. So comparing Z with the radius of the circular loop, it is almost negligible, very smallest radius. So negligible. Therefore, it is negligible, no? Therefore, almost is equal to Z square. This is negligible, that's all. So, B vector is equal to mu naught ER square by 2 of, this is negligible, no? That means R negligible, radius of the circle loop. Z square whole power 3 by 2 K cap. Okay? Then cancel, no? Therefore mu naught IR square by 2 EZ cube into K cap. Okay? Clear? Very simple questions. Okay, here, what is our radius of the current loop? I am correct or not? Okay, with respect to R, we can write one formula. That means area of the loop. Area of the circular loop. Current loop. Let us consider capital A. It is considered as caps A, area of the loop. It is equal basic formula. Already you have studied about this in mathematics. Area of circle. A is equal to pi r square. Okay? From this formula, we can write the formula for r square. What? Come on, tell me. R square, very good. R square is equal to A by K. So this value substitute in this equation. Okay? Come on, listen. So B vector. What is the reason for the symbol B vector? What is the reason? Very good, you are correct. Magnetic field is a vector quantity. Okay? It has both magnitude and direction also. Clear? So B vector is equal to mu naught I. R square is equal to A by pi, no? So A by 2 pi into Z cube. Okay? And listen here. At this point, indicate here. Multiply and divide by 2 this equation. Okay? So listen. B vector is equal to mu naught I A by 2 pi Z cube into K cap into 2 by 2. This equation we should be multiply and divide by 2. That's all. For our convenient. Okay? So B vector is equal to mu naught 2 I A by 4 pi Z cube into K cap. Clear? Yes. Yeah. This is equation number 1. Okay. This is equation number 1. Okay. Now we are going to comparing one famous equation or formula. You have already studied about this. Magnetic field along the axis of the very good magnetic dipole or Bohr magnet. Already you have discussed about this. Along the axial line and along the equatorial line. Already calculated in previous topic. I am correct or not? Yes. So I think page number 141. Take and see. Page number 141 in our textbook. Magnetic field of the Bohr magnet. This is south pole, this is north pole. Center of the Bohr magnet. At this point, that means at point P, the field, that means magnetic field B axial at a distance R from the center of the Bohr magnet. At a distance R at point P from the center of the Bohr magnet along the axis. I am correct or not? Come and tell me. B axial. Very good. Mu naught 2 pm 4 pi r cube into I cap. I am correct or not? Clear? I gives us direction of the magnetic field value. Clear? I am correct or not? Mu naught, page number 141. Take and see. Textbook, new textbook. Mu naught 2 pm by 4 pi r cube. Clear? This is the distance of the point P from the center of the bar magnet. Like this. Like this. Just to see this formula, you can write simply this formula. Mu naught for 2, okay. It is equal to Pm. What is meaning for Pm? Wait, I will say you. No problem. 4 pi, okay. Instead of Z here or that's all. Here denoted the distance of the point P from the center of the circular loop denoted by Z. But here the distance of the point P from the center of the bore magnet denoted by smaller. That's all. Okay. So this is equation number 2. Okay. Then comparing equation by 1 and 2. 1 and 2. Comparing 1 and 2 are here. 1 and 2. 1 and 2. Come on this side. See that equation. 1 and 2. B vector and B axial. 1 and 2. Comparing both equations. See here. Okay. Mu naught 2 Pm by 4 pi r cube is equal to first equation. Mu naught 2IA by 4 pi Z cube. Okay. Leave it directions I cap and K cap. No need. Mu naught 2 cancelled. 4 pi r cube, 4 pi Z cube cancelled. What is the remaining? Pm is equal to Ia. Okay. What is mean by here? Pm is called magnetic dipole moment. Magnetic dipole moment. In vector rotation, because of it is compulsory vector quantity, Pm vector is equal to I, this current scalar quantity, area A, compulsory vector quantity. So Pm vector is equal to P suffix m, that means is called a magnetic dipole moment. It is equal to I into A. So from this implies current loop behaves like a bar magnet, north pole, like north pole and the south pole. Okay. How sir? Right. I will explain very well about this to you. Don't worry. So here, how do you define this? Magnetic dipole moment of any current loop, it is equal to product of current and area of the loop. That's all. Come and tell me. How do you write when asking in your examination about definition for magnetic dipole moment? Yeah, tell me yourself. Magnetic dipole moment of any current loop is equal to, that's all, you can write with the help of this formula. Ia means I into A. Into means product. It is equal to product of current and area of the loop. That's all. Clear? Okay. Okay. Any doubt? Any doubt? Okay. Then, simply keep in your mind, already told you this formula to solving the problems. But because of this very simple to remember, NIA like NTA, AX, AX like perfume, AX perfume, like this, AX, that means A square plus X square like this. Because this is very simple for solving the problems in NEET examination, okay? But while writing your theory exam, just follow this. With the help of new symbols, R square and Z square, okay? So general formula, magnetic dipole moment of current loop is the formula. It is very, very important formula. This also used to solving the problems. Okay. Then, clear? Any doubt? See this? You can see this. Take notes. Direct formulas, no problem. But write this and see any doubt. Shall we move to next one? Yeah. Now, we are going to discuss about rabbit. I rabbit this. This is center of the circular coil. Rabbit. Okay. Okay, listen. Now, we are going to discuss about right hand farm rule. Right hand, sorry, thumb rule, not farm rule, thumb rule. Right hand thumb rule. Okay. What is the purpose of a right hand thumb rule? What is thumb? This finger. Okay. Right hand thumb rule. Already you guys studied about this. I am correct or not? To find out magnetic field around the current carrying conductor and also magnetic field along the axis of the current carrying loop also. You can use the single rule, that means a right hand thumb rule, you can use to find out field around the current carrying conductor and the field along the axis of the current carrying loop also. How? Come on, tell me. While using right hand thumb rule to find out direction of the magnetic field around the current carrying conductor, like this. This finger denotes magnetic field value, correct? No, you are wrong. This finger denotes direction of the current flowing through the conductor. Yes. These fingers gives as direction of the magnetic field around the current carrying conductor. Clear? Yes. Suppose the current flowing through this conductor like this, upwards. Okay, upwards. What is the direction of the magnetic field? This is the direction of the magnetic field. Clockwise or anti-clockwise? Outwards. Clockwise or anti-clockwise? Direction of the magnetic field. Come on, tell me. Very good, anti-clockwise. Okay. Suppose the current flowing through it downwards, like this. Upwards or downwards or west to north, north to west, no, anything. Okay, north to south, east to west, no problem. Current may be flow from any direction to any direction, no problem, nothing else. But you can find out easily, very easily with the help of this rule. Right hand thumb rule. So now current flowing like this downwards. The direction of the magnetic field around the current carrying conductor, very good, clockwise. That's all. Okay. The same rule we can apply to current carrying loop also, but a small different. In applying for current carrying loop, these fingers denotes very good current through the loop. This thumb, this finger denotes direction of the magnetic field along the axis of the coil. That is important. Okay, that's all. So now listen. This is the current direction. Okay, right hand thumb rule. When using find out direction of the magnetic field along the axis of the current carrying loop like this. Now this is current. Very good. But in state conductor, this gives us field, magnetic field direction. While using in loop, this gives us current. Now this finger gives us direction of the magnetic field. Okay. Now direction of the magnetic field like this along the axis of the coil. But here we can find out the direction of the moment also. Sorry, magnetic moment also in the circular loop. Okay. So if we curl the fingers like this. Okay. On the circular coil loop, the stretched thumb gives us direction of the magnetic moment. That's all, like this. This is the direction of the magnetic moment, like this. So direction of the magnetic moment and the plane of the coil perpendicular to each other. Okay. So magnetic dipole moment is equal to IA no. Suppose this loop contains n number of turns. You must multiply by n. Here n means number of turns. That's all. For one turn, IA vector. For n number of turns, n IA vector. That's all. Okay. So if you curl the fingers along the current flowing through the coil, that is important. The stretched thumb gives us direction of the magnetic moment. Okay. Okay. Now, right hand thumb rule. Okay, clear? Any doubt? Very simplest rule. This is a 2 mark question. Come on, tell me. What is the purpose of these fingers? Curl fingers. Yeah, in the direction of. Very good. In the direction of current in the loop. Okay. These fingers, curl fingers in the direction of current in this loop. Stretched thumb gives us direction of the magnetic moment of the current loop. Okay. Now we are going to discuss about one famous repeated 100% important questions in 2 marks. 100%. End rule. What is this? End rule. End rule. Before going to discuss about this, you must know about the magnetic field around the bar magnet. Okay, this is north and this is south pole. Direction of the magnetic field around the bar magnet always from north to south. You know that very well about this. Yeah, keep it in mind. Already told you, current loop as a magnetic dipole, correct or not? So current loop acts as a bar magnet and current flowing through it. That is important. Current loop means current flowing through it. Similarly, like this, this contains 2 poles, no, north and south pole. That is called a magnetic dipole or bar magnet. Okay. Starts from north pole to south pole. Emerge and merge. I am correct or not? So there are 2 poles, north pole and south pole. Similarly, when current flowing through it, that means through the circular loop, this circular loop also acts as a bar magnet. One end may be south and other end north, like this. That is the meaning of this title. Okay? Yes. Listen. Now, this outside, inside south to north, no need. But outside from north to south. Okay? But here inside, no field outside of the current carrying loop. Clear? Today you have studied about just in circular coil. Now, suppose from one end, when look at one end, the current, listen, current flowing through it, that means through the circular coil, in clockwise direction. That is important. What is the reason for acting of current this loop as a magnetic dipole? Due to current flowing it. Yes. So when current flowing through it in clockwise direction. What is this clockwise? This is clockwise. I am correct or not this. So this is clockwise. This is anti-clockwise. So when current flowing through the circular coil or loop in clockwise direction, when look to one end, the nearer end corresponds to south pole. பேசுறது புரியுதா? இது வழியா current clockwise flow ஆகும்போது இந்த end nearer end corresponds to south pole. Other end, there are 2 poles, no, only 2 poles. So this is south pole, will be this, other end will be north pole, that's all. And suppose, we'll put one end. Suppose the current, if the current flowing through the circular loop in anti-clockwise direction, nearer end corresponds to north pole, other end will be south pole, that's all. What's confused? How? Very simply remember this end rule, sir. Yeah, very, very simple. Listen, come and tell me, recall in your mind, when the current flowing through it in clockwise direction, this end, nearer end south pole, other end north pole. Suppose the current flowing through it in anti-clockwise direction, this end will be north, other end will be south. How, sir? Listen. Current in clockwise direction. Okay? Current flowing through it in clockwise direction, like this. This is clockwise. This end will be south. Okay, how? Okay? Yes means south. Draw one circle. This arrow mark. Like this. From this arrow mark. Like this. So now leave it. This is clockwise direction. Correct? Current clockwise direction. The symbol is now. Yes means south. So current is, suppose the current is clockwise direction. This end, near end, south pole. Other end, north pole. That's all. Okay. So listen, current no. This is current no. With the help of right hand thumb rule. Direction of the field like this. Along the axis of the circle. Inside, outside. Inside, towards, I am correct or not? So, field like this, towards the coil, towards the ball magnet, south, away from the ball magnet, north, away from the coil, north, that's all. Clear? So, clockwise direction current. This end, south pole, this end, north pole, that's all. And current anti-clockwise direction. Anti-clockwise direction. Like this. This is current direction. Field will be, this is current direction. Field will be like this. Okay? Away from the coil. But this side, towards the coil. Along the axis of the coil. So, this side clockwise, sorry, anti-clockwise, no? This will be, current is anti-clockwise, no? So, this side will be anti-clockwise. Already told you. Near end will be very good, north pole. Other end, south pole. How do you remember this? N, no? Like this. Like this. Already you have studied about this method in LKG and UKG also. Like this first. And like this. And like this. Yeah? Try a circle. So, near symbol. Here this symbol. So, now leave it. Now this is anti-clockwise direction. Correct? So, first end, nearest end, north pole. Other end will be south pole. That's all. This is the method to remember. Easy method to remember. Okay? So, it is very, very important rule. And a very important 2 mark question, 100%. So, compulsory. After studying about this, that means about right hand thumb rule and end rule, 2 marks in your pocket. Very, very important. Because there is no question paper without this question. Very, very important question. Because this concept widely used to solving the 1 mark problems in NEET examination. Very, very important. End rule. And right hand thumb rule also. End rule and right hand thumb rule. ER, ER, like this. Keep it in mind. ER, like this. End rule and right hand thumb rule. Okay? Okay. Take your textbook. Page number 167. 3.8.4. Just underline this. The magnetic dipole moment up to area of the loop. Underline this. And right hand thumb rule. Just to write from if we curl the fingers up to with the loop. And this is the end rule. So here not given the definition for end rule, only given points, that's all. Anti-clockwise first north pole, clockwise first south pole and north pole, anti-clockwise north pole and south pole, like this. Okay, just to follow this and underline this title. Okay, then read example problem 3.17. Come on, fast. Come on, read. What is the magnetic field? See this diagram. What is the magnetic field at the center of the loop shown in figure? That is the question. What is the magnetic field at the center of the loop shown in figure? That is the question. Okay, come on, tell me. What will be B value? That means B vector value at the center of the current carrying loop. Come on, how do you find out? With the help of end rule. No, you are wrong. End rule, Come on, tell me yourself. Very good. Right hand thumb rule. With the help of right hand thumb rule. Okay. This is the circular coil. Center of the circular coil. So here current direction represented like this. Okay. So two ends of this circular loop connected with the help of another battery. So at this point, current is split out like this. I am correct or not? So in upper hemisphere, current flowing like this. In lower hemisphere, like this. In upper hemisphere like this, in lower hemisphere like this. I am correct or not? So when using right hand thumb rule in upper hemisphere, like this, field, direction of the field along the axis of the circular loop or coil, like this. I am correct or not? Towards the board. Okay? Towards the board. In lower hemisphere, upper hemisphere like this, field value like this. This is the current, this is field, the direction of the field. Then like this. Inverse. Lower hemisphere. Okay? Upper, this is upper, in lower, like this. This is upper, this is lower. Upper side, current direction, magnetic field direction like this. Inverse, towards the board. Okay. In lower hemisphere, this is the current. Field direction, outwards. I am correct or not? Away from the board. Current value same. I am correct or not? So field direction, that means magnetic field direction, opposite direction in same magnitude. Opposite direction in same magnitude. Two persons. Force by two persons. Force is acting on me. This side 5 Newton. This side 5 Newton. Okay? Five Newton and 5 Newton. What is the resultant force of acting on this girl by these two persons? Equal magnitude in opposite direction. So resultant force 0 Newton. I am correct or not? Like this. Total value B1 vector due to current flowing through this coil like this. Inverse plus lower hemisphere due to current flowing through it away from the board, B2 but minus. Okay, but same magnitude. direction will be different. Therefore, 0. So, at the center of the circular loop, magnetic field value is equal to 0 because current, field, both are same magnitude but different direction. So, cancelled each other. So, at the center of the loop, field is equal to 0. Okay, clear? Okay, thank you.